Welcome to True Projects. In this video, we are going to explain about a project titled Kidney Stone Detection Using Yolo5. This study focuses on automating the detection of kidney stones in MR images, which address the challenges posed by indistinct boundaries and adherence of data. The proposed method involves several stages including the MR image processing, feature selection, transformation, classification by using the YOLO models. The aim is to improve the accuracy, efficiency, and reduce the diagnosis time. Leveraging the advanced object detection algorithms and image processing techniques, this research has the potential to transform the kidney stone detection and medical imaging, leading to the better patient care and diagnosis outcomes. The automated detection of the defect in MR images is of significant importance in various diagnostic and the applications. Due to the extensive amount of data in MR images and the presence of unclear boundaries, accurately segmenting and classifying the kidney stones becomes highly challenging. This research introduced an automatic approach to detect the kidney stones, aiming to enhance the accuracy, efficiency, and reduce the diagnosis time. In recent years, kidney stone segmentation in MRI has become a critical focus in medical imaging system. Preciously identifying the size and location of kidney stones play a crucial role in their diagnosis. The proposed diagnostic method, consisting of different stages like of processing of images, feature extraction and classification, and then extracting the features of the discrete wavelet transformation, and finally applying the normal models like of YOLO and employed them to normalize the kidney stone detection. These are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, Jupyter or Google Colab. Hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know the flow of the project, we need to discuss all these modules. The first one is importing libraries. In this module, the necessary Python libraries and frameworks are imported, like with the using of TensorFlow for deep learning, NumPy for numerical computations, OpenCV for image processing, and the flags for web development are loaded. And the second one is exploring the dataset. In this dataset, the containing of MRI images. The dataset consists of MRI scans of kidneys including both normal and cases. Data visualization techniques are used to understand the distribution of images classes. And the third one is image scaling and pre-processing. The image scaling having the various resolutions and dimensions. And this module, the images are scaled to a consistent resolution to ensure the uniformity. Additionally, the necessary image pre-processing steps are performed to improve the quality of the images by noise reduction, contrast adjustment, and filtering. And the fourth one is splitting the training and testing data. To evaluate the model's performance, the dataset is divided into the two parts, the training part and the testing part. The training set is used to train the YOLO models, while the testing set is assess the model's accuracy and making the prediction on the unseen data. And the fifth module is of building the model. In this module, the different modules are constructed and implemented. And the first one is yolo5, as a version of YOLO algorithm that improves upon its predecessors by introducing a more efficient architecture and better performance. It utilizes the deep neural network and convolutional layer to detect the object in images. And this model is trained on the large data set of the kidney stone images in the form of MRI to learn the feature that distinguish between the normal and the abnormal of the kidney stones. And the second module is yolo6. It is also another variant of the YOLO algorithm that might different architectural modifications and improvements when compared to the top yolo5. and it is specifically designed for object task and aims to improve the accuracy, speed, and other performance metrics. And the third one is yolo5. It represents the version to a greater variant of the YOLO algorithm, which have the further enhancements, modifications compared of yolo5 and v6. Training the model. Once the YOLO models are constructed, the training process begins. During the training, the models are fed with training data and they learn to optimize the parameters to accurately detect and classify the kidney stones in MRI images. The training involves multiple iterations until the model achieves the sufficient accuracy. And the seventh one is users view the input. The project includes a web-based interface using the Flask framework, allowing the user to interact with the system. Here, user can upload the MRI images of the kidneys through the web application. And the eighth one is the given input is pre-processed for prediction. The user provided MRI images are pre-processed before being fed into the trained YOLO model, which for prediction. The processing step ensures that the input images are in the suitable format for the model to make the accurate prediction. And the ninth one is trained model is used for prediction. The pre-processed MRI images are passed through the models for the prediction. These models will detect and classify the kidney stone in the image and classify it. And the final one is final outcome is displayed. The prediction made by YOLO models are presented as the final outcome. The web application interface will display the result to the user in the form of as an image with displaying the information within it. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files and template file. This folder consisting of different HTML pages which are used in this project. It typically includes the files like of home, after, index, notebook, sign in and sign up. And the static folder consisting of the files that are related to the CSS, JavaScript and Bootstrap. And the test train are the data sets that consisting of the MRI images within it. And the app.py is a file likely contains the information related to the front-end logic. It could include the code written in Python that handles server-side operation such as processing the user request, interacting with the database, and generating the dynamic content to be rendered in the HTML template. And the IPYNB file is a Jupyter notebook file which contains the information of combination of code, graph, outputs of all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for data science. And the signup.db is a file appear to be the database file used to store the user information. And to execution of the project, first we need to copy the address of this folder and need to open the Anaconda prompt and click on open button, and we get a screen like this and we need to enter the disk. And this folder is present in fdisk, so I am writing of F command and click on open button, enter button, and then we need to write a command like of cd space and paste the address of the folder and click on enter button. By this we need to write another command of python space app.py. Here, by using this command and the command Anaconda prompt, it will execute the Python script and perform the runtime check for any syntax errors or logical issues, and click on enter button. After running this app.py file, the Flask framework will host the application locally at the default address as of like this and the port too. We need to copy this local link provided by the framework and paste it on any web browser, and I prefer to use the Chrome. I'm opening the Chrome and pasting this address and click on enter button. Here we get as home screen like this. On the home screen, we can see that of home button, login button, which is used to initiate the process, and click on login button. It redirected to this page. It consisting of login and of sign up button too. The sign up button is used to initiate the registration process. By clicking it, it will take to the registration page where we can provide the necessary details to create an account. But I have already signed up in this page, so I am using the sign in button and going to the login page, and I am entering the username and password like of admin and click on login button and click on OK button too, and it redirected to the another page where it contains of home, notebook and sign up. And the home as the home page, notebook consisting of the code, having the training, testing, sampling and graphs within it of each within detail, and sign out as of closing this web application. And here we need to select the choose file button. By this, it redirected to the sample folder consisting of different MRI images, and we need to select any one of it, and I'm selecting this and click on open button and then click on upload button, and we can see that the kidney stones of 0.80, kidney stones of 0.70 as of like this format, and click on back and we can get this screen. Here we can choose the another file, and I'm selecting this one and click on open button and then click on upload button. Here we can see that it is a normal image where doesn't have any kidney stones within it. In this way we can predict the kidney stone and by using the MRI images. And in conclusion, the project provides a comprehensive overview of the latest advancement in the MRI-based kidney stone segmentation technique. Many current methods for segmenting the kidney stones rely on MRI images due to their non-invasive nature and excellent differentiation of the soft tissues. These methods employ classification and clustering techniques, utilizing the various features and considering the spatial information within the local neighborhood. The objective of this technique is to provide the essential assessment for diagnosing the stone monitoring and treatment planning, while also delivering the robust result within a reasonable computational time frame.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.